this assessment, we're asked to use our pKa table to assign a pKa value to a compound that is not exactly represented by the table. We'll do this for the molecule cyclohexane. Now, the most acidic proton is indicated, this one here. If we think about what it's attached to, it's a hydrogen attached to an sp3 hybridized carbon with no other functional groups around. The other way to think about this is it's a carbon with 4 bonds, one of which is to the hydrogen. Now, if that proton is removed, we're going to end up making a conjugate base that looks like this, with a negative charge on the carbon. That's kind of the other way we can approach this problem, is when this proton comes off, here's what the conjugate base is. Can we find a value in the table that mimics the starting acid as well as the conjugate base at the end? And so what we're looking for is a carbon with 4 bonds that upon deprotonation becomes a carbon with 3 bonds and a lone pair. Looking at this cut out portion of the table, we see that methane is a CH4, that's 4 bonds, one of which at least is to hydrogen. And the product, the conjugate base of that, is the methyl anion, carbon with a lone pair, a negative charge, and 3 bonds. Carbon, 4 bonds, at least one to hydrogen, carbon with a negative charge, and 3 bonds. Our approximate pKa value for this proton then will be 50.